Okay, so let us get to the section 5.6, which is talking about the integration by parts. Okay, now the product rule states that if f and g they are differentiable functions, then if we take the derivative of the product f times g, then I will have f of x times g prime of x plus g of x times f prime of x. Then now, if we work with the antiderivative, okay, to the left-hand side, okay, and then we do the rest of it is basically we take the integration, okay. Okay, and then now, what do we have? We will have a product f times g is equal to the integration of f of x times g prime of x dx plus the integration of g of x times f prime of x dx. Then, if we move this term to the other side of the equations, then we are going to have like f of x times g of x minus the integration of g of x f prime of x dx is the integration of f of x g prime of x dx. Okay, so then this is about the integration by parts then. Okay, so now you will see that last section when we talk about the substitution is related to the composite functions. This section is related to the product rule. Okay, and then let's see how we actually work using the integration by parts to actually to work out the problem then. Now, if we let u equal to f of x and dv is g prime of x dx. Okay, so then basically this is u. This is dv. Then in this case, what we are going to have is we are going to have u times v. Okay, because again, if we use antiderivative, right? V basically is equal to g of x is equal to v times du. Okay, this is exactly how we get to the integration by part then. Okay. Okay, then of course, if we want to work with the definite integral, then what we need to do is we just integrate f of x times g of x. We integrate between a and b, and minus the integration of a of from a to b of g of x f prime of x dx. Then, okay. Now, what is our goal? Our goal is using the integration by parts is to obtain a simpler integral, okay, than the one that we start with. Here are three guidelines, okay. Choosing u so that u prime is simpler than u itself, and v prime so that v is equal to the integration of v prime dx can be evaluated. Sometimes v prime equal to 1 is a good choice, okay. Okay, so how do we actually work on this problem right here? Okay. First of all, if I have this problem, I would like to integrate, okay, x times cosine of x dx. Then, what is my first choice? Okay, so we could actually, again, we could actually let u equal to x, and then dv equal to cosine of x dx. Okay, so we, now, in this case right here, then you will see that what happened is du is equal to dx. Okay, and then what is v? V will be negative sine of x then. Okay. Oh, my bad, because it's the derivative of sine is equal to cosine, right? Okay. Okay, then now you will see that one thing about this is we let u so that u prime is simpler, okay, to u itself, and also we let v prime the v, so therefore we will be able to find v. Okay, okay, then let's see how we actually work it out the problem now. Now remember, in this case, we would like to again integrate x cosine of x dx. Okay, now integration by part is will be, okay, so it is u dv is equal to u times v minus integration v du. Okay, so this is what we are looking for. So therefore, in this case, okay, we know that u is x and v is psi of x and minus v du, right? Okay. And now, after we have this, then of course, we have psi of x minus. We know that the integrations of sine is negative cosine outwards. Then, as the result, we will have x psi of x plus cosine of x plus c. Okay. And how do we actually check? We could actually take the derivative of x psi of x plus cosine of x plus c, and then to see what is this equal to. Then it is equal to the derivative of x psi of x plus the derivative of psi of x times x plus the derivative of cosine of x, and then plus 0, right? And then, of course, we will have psi of x plus x cosine of x minus psi of x okay. So then you will see that my integrand is x cosine of x then. Okay. So therefore, again, this is actually is how we actually do the integrations by parts. Okay. Now, of course, sometimes it is really hard to know which one I would like to that's mean to assign to u, and then which one is the v, right? Now, here is a way to do this. Okay, so a mnemonics device, which is helpful for selecting u when using integration by part, is the active principle for precedent for u. Okay, precedence for u. This is actually is we follow this L for logarithmics, like log of x, log base 4 of x. I is for inverse trig, okay, tangent inverse, sine inverse. Algebraic, okay, like x squared, x to the power 4. T for trig, so sine or cosine, and E is for exponential. Now you will see that based on this device right here, okay, or maybe we just work with the order, then you will see that here, x is algebra, right? And then cosine is a trig. So that's why in this case right here, we will let u equal to x, okay? Okay, then now let us work with the next one here, number 2. Now again, you will see that we have algebraic x and then exponential. So therefore, in this case, what we would like to do is we would like to let u equal to x, and dv will be e to the 2x dx then. Okay. Then now, of course, we will have du equal to dv, and then v will be 1/2 e to the 2x then. Okay. And then now, when we have this, then we will have x e to the 2x dx is equal to x times 1/2 e to the 2x minus 1/2 e to the 2x dx now. Okay. And of course, I will have 1/2 x e to the 2x minus 1/2. Okay. Again, you will see that e to the 2x basically is 1/2 e to the 2x plus c. Okay. Then, of course, right now, I will be able to simplify. Oh, that's it. Okay. Now, of course, you could actually take the derivative and then to see if you could back to the integrand then, right? Okay, now this is actually is weird that I only have natural log of x. Then in this case, how do we actually work it out the problem? Okay, now you will see that this is exactly what happened is sometimes we let v prime equal to 1. Okay, then this is actually maybe it is a good choice. Okay, so how do we do this? Okay, so what I'm going to do it here is I will let u equal to natural log of x, and then I will let db is equal to dx. Then. So if this is the case, then I will have b is equal to x, and du it will be 1 over x dx, right? So this is what we're going to have. And then now, let's see. So I have integrate the natural log of x dx. It will be natural log of x times x minus x, okay, dx. 1 over x dx. Okay. Okay. Then now you will see that what happened here, I will have x natural log of x minus integration of dx, right? So then of course we know that here it will be x plus c now. Okay. So then this is actually is one way to do the problem. Okay. So therefore, again, sometime maybe just have dv equal to dx, okay, to work out the problem. Okay. So then the next one, if I have x squared times psi of x dx, okay. So to this one right here, again, you will see that x squared is before trig, before sign. So what I need to do here is I would like to let u is equal to x squared, and then dv is psi of x dx then. Okay. Okay, so then now, if I already have this one, then what I should do here is, maybe let us finish this. So I will have v is negative cosine of x, and then du, it will be 2x dx now. Okay, so then now I will have x squared psi of x dx is uv x squared times negative cosine of x minus v du. Okay. Okay. Then now, this is actually is. Let's see what do we have here. Okay. So you will see that, oh, it seems that we need to do another integration by part to actually to take care of this one. Okay. So therefore, let us do another one. So now I will have u sub 1 is actually is equal to x, and then I will have d v sub 1, it will be cosine of x dx. Okay. So to some problem, we may need to do more than one times, right? For the integration by part, okay? Then now we will have v sub 1 is equal to psi of x, and then du sub 1 is dx now, okay? And now, of course, I will have negative x squared cos of x, okay? This one won't change, right? And then now I will have 2 times here is the 1. So I will have x times psi of x minus v du. So I will have psi of x dx now, okay? Okay, then now we have negative x squared cos of x plus 2 times x psi of x. And then to this one right here, we know that we are going to have a negative cosine of x, right? And then plus c. Okay. And now plus 2x psi of x, and then plus 2 cosine of x plus c. Okay. Okay. Okay, so the next one is I would like to talk about the tabular method. Now you will see that the tabular method is really similar to what we just did in for number 4, okay? But in this case right here, we actually let's try this technique, the tabular method right here, to see if we will be able to get the result really quick, okay? Now, when we integration by part is need more than once, just like what we just did, you are actually doing integration by parts recursively, okay? Like example number 4, we could use the tabular method to solve the integrations, okay? So how do we actually do this? So in this case right here, we are going to, same thing, we would like to have, this one is x squared, and then the dv is psi of x, okay? Just like what we have. And then now what we're going to do here is, to the left side, we are going to take the integrations. Take the derivative. So you will see that to this one basically is 2x, and then the next one will be 2, right? And then the next one will be 0, okay? So this part, we take the derivative. And then to this side right here, we are going to take the integrations. So therefore, then to this one, it will be negative cosine of x, and then this one will be negative sine of x, and then the next one will be a cosine of x, right? Now again, remember, to the right side of the table, we integrate. The left side is we take the derivative. And then now, how do we actually work it out the problem? So to this one, and then minus, and then plus, and then so on and so forth. So therefore, again, we were going to use a kind of like the alternating sign. So plus, negative, plus, negative, plus, negative, and so on and so forth, right? Of course, the next one I don't need to, because this side right here is already 0. Then let's see if this is the answer that we have, okay? So then means x squared psi of x dx is equal to, this is plus, so I have negative x squared cosine of x, and then the next one is negative, so I will have plus 2x psi of x, and then the next one will be plus 2 cosine of x plus c. Okay. Now let us compare the result, okay? Then I have negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c. Wow, that's work, huh? Okay, then right now it is your turn. Now go ahead and try number 5, okay? And then to see if you could actually get to the result, okay? Now again, remember based on the reality that the algebraic is actually before exponential. So you should let u equal to the x to the power 4 in this case then, right? Okay, so let's try this. Okay, and then now I have e to the 7x. So remember we integrate. So therefore I will have 1 over 7 e to the 7x. And then I have 1 over 49 e to the 7x. And I have 1 over 343 e to the 7x. I have 1 over 7 to the 4 power e to the 7x. The number is just too big. Okay, I have 1 t to the 7 to the 5th e to the 7x. And then I think that I could stop it here, huh? Okay, so again, remember to this one plus, minus, plus, minus, plus, okay? So then my answer in this case right here, it will be 1/7 x to the 4th e to the 7x minus, so I will have 4 over 49 x to the power 3 e to the 7x plus 12 over 343 x squared e to the 7x minus 24 over 7 to the 4th x e to the 7x plus 24 over 7 to the 5th e to the 7x plus c. Okay, yeah. And of course, again, if you have time, then feel free to take the integrations, okay? Okay, so then now the next problem is actually what if I have x times 5 to the x now, okay? So to this one right here, okay, so and of course I will let u is equal to x and dv is equal to 5 to the x dx, okay? Now one thing about this is, remember when we try to take the derivative, okay? So if I have 5 to the x, if we take the derivative, it will be natural log of 5 to the x, okay? So this is what we have. So therefore, when we try to take the integrations, then I will have v, it will be 1 over natural log of 5 to the x then, okay? Because again, when we take the derivative, then we would like to cancel the natural log of 5, right? And then, so I will have du is equal to dv. And now, x 5 to the x dx is equal to, I will have x natural log of 5 to the x, and then minus v du. So I will have then dx, okay? Okay, so this is what we have. Then, of course, right now, we are going to have x 5 to the x over natural log 5 minus let me take out this. And of course, my answer will be x 5 to the x over natural log 5 minus 1 over natural log 5 times 1 over natural log 5, 5 to the x plus c. Okay. Then, yeah. Okay. And this is my answer. Okay. Okay. So now, this is actually is number 7 is really special. Okay. This one right here is actually is kind of like fun to have to work it out this problem. Okay. Now let's see why this is fun. Okay, so now you will see that to this one, I would like to integrate e to the x sine of 2x dx. Again, based on the reality, then what do we need to do first? Remember, trig is before exponential. So I would like to let u is equal to sine of 2x. Okay, and then of course I will have db is e to the x dx then. So then now I will have v is e to the x and du will be 2 times cosine of 2x dx. Okay, so this is what we have. Okay, so now then let's see. I will have e to the x is sine of 2x dx is equal to u times b e to the x sine of 2x minus b du okay, this is what we have. Okay, then now we will have e to the x sine of 2x minus 2 e to the x cosine of 2x dx. Okay. Okay, and now I have to do the integration by part again. So I will have u sub 1 is cosine of 2x, and then dv sub 1 is e to the x dx. Okay. Then of course I will have v sub 1 is e to the x, and du sub 1, it will be u negative 2 sine of 2x dx then. Okay. Okay, and now I need to be careful. So I have negative 2, okay, using a square bracket. Okay, then I will have u times b, so I have e to the x times cosine of 2x minus e to the x negative 2 sine of 2x dx. Okay. Okay, so let us take care of this one. So I have e to the x sine of 2x minus 2 e to the x cosine of 2x. So I will have negative 4 e to the x sine of 2x dx. Okay. It seems that we could do it forever, huh? Okay. But do you notice this one and this one? They're the same, isn't it? So what I'm going to do here is I would like to move this whole term to this side. So I will have this plus 4 e to the x sine of 2x dx is equal to e to the x sine of 2x minus 2 e to the x cosine of 2x. Okay. Okay. Then now, what I'm going to do here is I would like to add a c, okay? Because when we take the derivative, then the constant is gone, right? So we do need to have this. So I will have 5 e to the x sine of 2x dx is equal to e to the x sine of 2x minus 2 e to the x cosine of 2x plus c sub 1. Okay. And now, of course, what we are going to do here is we are going to divide everything by 5 now. And now I will have minus 2 e to the x cosine of 2x over 5 plus c, okay, where c is equal to c sub 1 over 5. Nice, huh? Okay. Okay, so then let us try to work on number 8. Okay, now this one right here, again, is only have cosine inverse x dx. Okay, so therefore again, now you will see, do you remember this? When we only have one functions, okay, then it's kind of like we have the natural log of x here. So what we are going to do is we let dv is equal to dx here, okay? This is again how we actually take care of this problem now. So then now I will let u equal to cosine inverse of x, okay? And then dv is equal to dx, okay? Now of course, right away, we know that here v is equal to x, okay? So I don't know if you remember the derivative of cosine inverse of x, okay? Now if you don't, then here is how we do this, right? In calculus, okay? Back to the calculus. So we would like to, again, if we have u equal to cosine inverse of x, that means cosine of u is equal to x then, okay? And now what we're going to do is we are going to take the derivative to both sides of the equations. Then, of course, we know that the derivative of cosine is a negative sine of u prime is equal to 1. Then u prime will be 1 over negative sine of u. Okay. Then one thing about this is from here, if we have a triangle, then if the angle here is u, then meaning u is the reference, right? Cosine of u basically is what is the adjacent over the hypotenuse. Then in this case, to this side right here, okay, so if this is like y, then now I have x squared plus y squared is equal to 1. Then y squared must be 1 minus x squared. Then y will be square root of 1 minus x squared. Then to this triangles, what is sine of u? The sine of u basically is will be a square root of 1 minus x squared. Okay, over 1. So therefore, in this case, I will have u prime is 1 over, okay, it's a negative thing, 1 over square root of 1 minus x squared, okay? So therefore, again, du is dx over negative, don't forget the negative, the square root of 1 minus x squared. Okay. So again, if you remember how to take the derivative of the inverse, that's great. But again, if you don't, then we have a way to work out, right? Okay. Then now let us finish this problem now. So I have the integration of cosine inverse of x dx is equal to uv minus v du. Okay. Okay. So after we have this, then what do? We have to use a substitution again. Okay, to work with this one right here. Okay. So to this one right here, what we could do here is we could let u, we already use it. Then how about u sub 1? How about w is equal to 1 minus x squared. Okay. Then I will have dw is negative 2x dx. Then of course we will have dw over 2 is equal to negative x dx. Okay. Okay, so I will have this one, it will be 1 over square root of w of the w over 2. Okay. Okay. Okay, so then now we are going to have x cosine inverse of x minus square root of w plus c. Then of course we have x cosine inverse of x minus square root of 1 minus x squared plus c. Okay, so yeah. Okay, so let us look at the last two problems. Okay. Now to this one right here, we would like to use the integration by part, the substitutions of both. Okay, to work out the problems. Okay. So then now you will see that in this case right here, substitution, right? You will see that this is my inner functions. So why don't we let u equal to natural log of x, and then we will have du is 1 over x dx, okay, or dx over x. Okay, then now we will have this one is natural log of u, and then du. Okay. Okay, so then now we need to use the integration by part, right? So we will let u is equal to natural log of u sub 1 now, and natural log of u, and then dv sub 1 is du. Okay. Then I will have v sub 1 is equal to u, and du sub 1 is 1 over u du. Okay, so then now what we are going to do is we will have uv So I will have u times natural log of u minus u du. And now my answer will be u natural log of u minus u plus c. Okay. And now what is u? U is natural log of x, natural log of x minus natural log of x plus c. Fun, huh? Okay. Ooh, the last one. Now this one right here, I would like to find out what is f of x equal to. Okay. So assume that the integration of f of x e to the x dx is equal to f of x e to the x minus x inverse x to the negative 1 power, okay, not inverse, it's x to the negative 1 e to the x dx. Okay. So in this case, then probably this problem right here, we are going to work with a integration by part now. Okay. So then let's see. If I let u equal to f of x, and then dv is equal to e to the x dx. Okay, so this is what we have. Then now, then of course I will have du is f prime of x dx, and then v will be e to the x then. Okay, okay. Now, if I do it this way, then what I'm going to have is we will have uv left hand side. Okay, so it will be uv, so I will have f of x e to the x minus integration of v du. Okay. Then now, if we compare to the right hand side, we find out that the f prime of x is equal to x to the negative 1. Okay. Then, if this is the case, if we take the integrations, okay, it will be integration of 1 over x dx. Then we know that this is the natural log of absolute value of x plus c. So therefore, in this case right here, I found out that my f of x is equal to natural log of x plus c then. Okay. So again, this is actually the last problem is kind of like a little bit tricky, okay, to use the integration by part to help us to finish the problem then. Okay, thank you. Then now again, integration by part is actually sometimes if you have a products, okay, then maybe we could use integration by part to finish the problem. Okay, and again, try to when you choose which one to be u, which one to be dv, then you could using this order right here to help you to figure out. Okay, okay, yeah. Then thank you.